JMO 2024 problem 5. It says find all functions f from R to R, real numbers to real numbers that satisfy f of x squared minus y plus 2y f of x is equal to f of x plus f of y for all x and y in real numbers. Okay. For solving functional equations, one idea is you should consider again small examples, for example, 0, 1, -1. Idea 2, you should consider special cases, for example, x equals y and something like that. And there are lots of things you should consider. Is it 1 to 1? And if you have complicated term, try to get rid of that. I will tell you how. Now here, let's first consider special cases. For example, the first special case, because we have from real numbers. If you had, for example, from positive real numbers to positive real numbers, we couldn't say x, y, 0. Here, because they are from real numbers to real numbers, the function, we can consider x is equal to y is equal to 0. Then left hand side would be what? F of 0. This one's 0 because y is 0 is equal to f of 0 plus f of 0. We can cancel f of 0 from both sides, and so f of 0 is 0. Here we can consider, we can say that, suppose that f of 0 is a constant, we know a constant c, then we can say f of c is 0, okay? So let's put a box around the things that maybe can be useful. It's first one. Now, let's consider only x is equal to 0. Then it would be what? F of -y plus 2y f of 0 is equal to f of 0, which we said it is equal to 0 plus f of y. So we can cancel this. F of 0 is c. Why we can cancel this? Because of this. So we can say f of -y plus 2yc is equal to f of y. Okay. Let's put a box around this second important result. Now, let's consider y equals 0. Then it would be f of x squared here. This is 0 is equal to f of x plus what? Plus f of y, which is plus f of 0. F of 0 is c. So, let's again put a box around this equation, and we can call it third result. But always when you want to solve a problem like this, you don't know which of the results are useful, which of them not. So we write all of them. We label them, for example, 10 results. And maybe at the end you will understand that, okay, 6 of them were useful. In the beginning, how can we understand which of them are useful? We cannot. So write down all, or put a box around all results that you think maybe can be useful. Now, next step, we can consider what? We can consider x is equal to y. Then it would be what? F of x squared minus x plus 2x f of x is equal to f of x plus f of x. Okay. Let's put a box around this one. Fourth result. Okay, next, when we have an equation like this, and one term is not good, f of x, okay? Sometimes you have a complicated term like this, and we want to get rid of that. Okay, so idea 3. Get rid of complicated term. Complicated term. Okay, how I don't like this. So I consider y1 and y2, 2y1 and f of x squared minus, now with y2 plus 2y2 f of x. Here at the end we can understand that it's not useful, but in the beginning we don't know which of them is useful. So I tried also this one, and if we subtract These two things will be cancelled. This part will be what left hand side? Will be f of x squared minus y1 minus f of x squared minus y2 plus 2f of x times y1 minus y2 is equal to f of y1 minus f of y2. Okay. Now let's put the box around this part. We can write it as fifth result. Okay, now in next step, I want to consider this one. I want to see, for example, how can we get rid of this part. So if this one is 0, then f of 0 we know is 6. If I consider y is equal to x squared, then it will be f of 0. We call this one c. Now first box here, f of 0 c plus 2x squared f of x is equal to f of x plus f of x squared. Okay? And okay, if you write it in terms of c, we can say, can we simplify? Okay, so let's put a box around this part. Let's call it a sixth result. Okay. Okay, now let's consider all things that we reach, which of them are similar. This one and this one can be useful because both of them have f of x squared and f of x. So let me consider third result and this one. Okay. If we combine these two things together, we can, instead of f of x, I can write f of x squared minus 6. So let's write it. From 3 and 6, we can say, okay, c plus 2x squared f of x, c plus 2x squared f of x is equal to f of x from third one is equal to f of x squared minus c. So f of x squared minus c plus f of x squared. Okay. If we take negative c to left hand side and simplify, it's 2c plus 2x squared. F of x is equal to 2f of x squared. Okay, and now we can divide both sides by 2. So c, we can switch left hand side and right hand side. F of x squared is equal to x squared f of x plus c. Okay, we can call it result number 7. Okay, and that can be useful. Why? Because we proved that f of c is 0. Okay, so if I replace x with 0 in this one, then f of 0 is equal to c. So we've not reached any important result. Okay, so we've reached an obvious result. Now let's see things that we have. Let's consider again third result. From here, if we consider f of negative x, okay, f of negative x squared is x squared. We change x to negative x is equal to f of negative x plus c. This is equal to this one. This is equal to this one. So we can conclude what? We can conclude f of x is equal to f of negative x. One term is left for each of them. So that term should be equal. And in next step, we can say what? Here again. If we consider this one, if we change again x to negative x, then we have c plus 2x squared f of negative x is equal to f of negative x plus f of x squared. We know this and this are equal because of this part. So let me draw a box around this. It will be result number 8. So because they are equal, and this part also equals, c equals, so we can conclude 2x squared f of x is equal to 2x squared f of negative x. Consider that x is not 0, okay? If x is not 0, then we can conclude f of x is equal to f of negative x. And because when x is 0, we know f of 0 is equal to f of y. We should consider x is not 0 because we want to cancel x squared. It shouldn't be 0. Then we can conclude this. If x is 0, then f of 0 is equal to f of negative 0 because negative 0 is 0. So we can remove this and it's correct for all x's. So let me draw a box around this. It is 9. And f of x is equal to negative x. If we use 9 here, this one is equal to this one. So we can say 2y c 0, so c is 0. Okay, so let me combine this from 2 and 9. 2 is this one, 9 is this one. Okay, so from these two results, we can conclude what? We can say, okay, we can cancel these two things. So 2yc is 0. And then we can select one y that is not 0. You can say, for example, y is 1. Okay, when you want to use this. So 2c is 0, so c is 0. So let's put a box around this one, and it will be our 10th result. Okay, because c is 0, we can write this one. And we can say what? Because c is 0, we can write f of x squared is equal to x squared f of x. Also, we can say what? We had something about f of x. Because c is 0, you can cancel this. And f of x is also f of x squared. From 3 also, you can say f of x. Also by using 3, we can say f of x is equal to f of x squared is equal to x squared f of x. Okay? So, let's put the box around this one, and it will be result number 11. Okay, because now we have f of x that is equal to two things. Let's calculate f of x two different ways. So we can say what? If we use this part, we can say f of x. If we use this part, is f of x squared. So we can write f of x squared. And then we know f of something. We want to use first one, last one. F of something is that squared. So here x squared f of x squared. So it would be x to the 4 times f of x squared. Then we should use second one and third one. F of x squared is x squared. So x squared times x squared f of x, which would be x to the 6 times f of x. Okay, so let's review what we did here. Suppose it is 1, 2, 3. This part I said, okay, f of x is f of x squared. So I used 1 and 2. And then f of x squared is equal to this. We used 1 and 3. And then f of x squared is equal to x squared f of x. So we used 2 and 3. Now let's calculate it with another way. We can say f of x. Here you can say, okay, it is f of something. We want to use 1 and 3, okay? So f of something is that thing, which is f of x squared, and f of x. And then for f of x, we want to use this 1 and 3. So it will be f squared x plus, or let's write like this, f of x squared, f of x for 1 and 3. It's what? X squared f of x. So it will be x squared times f of x cubed. So we can conclude these two terms are equal. So x to the 6 f of x is equal to x squared times f of x cubed. Now we can do what? We can cancel x squared from both sides. Consider x is not 0, okay? Because when x is 0, we know obviously it's correct. And at the end, we will consider. Let's divide both sides by x squared. So it would be x to the 4. And let's do something. Suppose x is not 0, f of x also is not 0, okay? At the end, we say, okay, one case is that f of x is 0. So if we simplify, we can divide by x squared f of x. So it will be x to the 4 is equal to f of x squared. So from here, we can conclude f of x is equal to plus minus x squared, okay? From real numbers to real numbers. So we can conclude f of x can be 0, because here we consider it's not 0, or plus minus x squared. Now we want to see, is it possible that for some x's f of x equal to 0, for some x's f of x equals plus x squared, or something like this? Because we have three different values. X squared, for 0, all of them are equal. Let's consider the cases that are not 0. I want to see, is it possible to have both 0 or x squared, or both 0 and negative x squared, or both negative x squared and x squared? I want to reject all of them. Then at the end, we can conclude all f of x should be 0, all f of x should be x squared or negative x squared. So let's check these cases. Suppose, okay, let's copy our main equation. Okay, this one. And here, suppose that f of, for example, x1 is 0, and f of x2 is, or let's write y1, is what is y1 squared. We want to check this case, okay? And we can consider that x1 and y1 are not 0. Why? Because if they are 0, then for f of 0, all of them satisfies. So 0 is not important, because 0 squared plus minus 0 squared would be 0. For non-zero values, we want to see, is it possible that one of them equal to 0, one of them y squared, or not? So if we replace f of x1 squared minus y1 plus, because f of x1 is 0, we can cancel this. F of x1 is 0, we know f of 0 also is 0. We proved, where we proved here, we proved C0 in short. Result number 10. So f of 0, 0, f of y is what? F of y1, okay? Which is y1 squared. Now we can say what from here? You can say, okay, this one is 0. It's not possible. We have three cases for this, because we said each function can be, let me put a box around this. It will be result number 12. From result number 12, we know that this one is 0, or x1 squared minus y1 whole squared, or negative x1 squared minus y1 squared. Let's check all of them. 0 is not possible, because then 0 is y1 squared and y1 would be 0. We said in the beginning y1 is not 0. If we check next one, x1 squared minus y1 squared is equal to y1 squared, then we can raise the left hand side to the power of 2x1 to the 4 plus y minus 2x1 squared y1 plus y1 squared is equal to y1 squared. We can cancel y1 squared from both sides. We can divide both sides by x1 squared. So x1 squared minus 2y1 is 0. And okay, we can conclude what? We can conclude x1 squared is equal to 2y1. Okay, it is case 1 that we are considering. Okay, case 1. Now, in next step, we can say what? We can consider x1 and negative y1, because we know f of negative y1 is equal to f of y1. We proved this in result number 9. Now, if we consider this part, f of x1 squared plus y1, again, this part is 0, because f of x1 is 0, this one 0, f of y1, f of negative y1, which is f of y1, y1 squared. Again, you can say this part can be 0 or x1. Sorry. I didn't consider last case, this one. We can reach contradiction for this one. Why? Because from here, Negative x1 squared minus y1 whole squared is equal to y1 squared. You can take it to right hand side. So x1 squared minus y1 squared plus y1 squared is equal to 0. And because they are real numbers, they are at least 0, so we can conclude both of them should be 0, y1 0, that's a contradiction. So the only thing that we can consider is what? X1 squared is 2y1. Now here again for 0 we can reach contradiction for x1 squared plus y1 whole squared and negative x1 squared plus y1 whole squared. Again, for this one, you can reach contradiction like this. You can take this to right hand side and you can see it would be 0. For this one, if we expand x1 to the 4 plus 2x1 squared y1 is equal to y1 squared. You can cancel also y1 squared, it would be 0. So if you divide both sides by x1 squared, it's not 0, so you can write x1 squared plus 2y1 is 0. Now, if we combine this one and this one, x1 squared is 2y1. So if we replace 2y1 plus 2y1 is 0. So 4y1 is 0. So y1 is 0. Again, that's a contradiction. Okay, so case 1 is not possible. We've reached contradiction for case 1. Now let's consider case 2. 0, negative x2. Again, by similar approach, we can reach contradiction. x1 f of, okay, let me write case 2. F of x1 is 0. F of y1 is negative y1 squared. X1 and y1 are not 0. Okay, so we write f of x squared, x1 squared minus y1 squared minus y1. This one 0, this one 0, because f of x1 is 0 is equal to f of y1. Like previous case, you can say, okay, f of x1 squared plus y1 also is equal to f of negative y1. Both of them are negative y1 squared. They are equal. We proved this before. Now, we should check again different cases. We know it cannot be 0. And like previous case, it cannot be this one squared, because then you can take these to left hand side. Sum of 2 squared 0. Each of them should be 0. So the only possible case here we have is negative x1 squared minus y1 squared is equal to negative y1 squared. And for this one, x1 squared plus y1 whole squared, negative of that is equal to negative y1 squared. Okay. Now from this part, we can cancel negative 1 from both sides. Here we can cancel y1 squared from both sides, x1 to the 4 plus 2x1 squared y1 is 0. Minus. And from here, x1 to the 4 minus plus 2x1 squared y1 0. Then if we subtract this minus this, or we can add 2x1 to the 4 is 0, so because x1 is a real number, x1 is 0, that's a contradiction. Okay, so we reach contradiction for the second case. Now, third case. X squared negative x squared. So third case, so let's write f of x1 is x1 squared, f of x2 is f of y1, let's write y1, is negative y1 squared. Okay, and our main equation is what? Is this one. So let's replace again. We can say what? F of x1 squared minus y1 plus 2y1. F of x1 is x1 squared. F of x is what? X1 squared. F of x1 squared is, we should consider. Because we proved f of x is what? We proved f of x is x squared f of x, okay? So because this one is x squared f of x, and we know f of x1 is x1 squared, so x1 to the 4 minus y1 squared, okay? And also we can say what? We can say f of x1 squared plus y1 minus 2y1. Here we consider x1 and negative y1. X1 squared is equal to, again, x1 to the 4. F of y1 and f of negative y1 are equal, so both of them will be negative y1 squared. Okay, now we can conclude what? F of x1 squared minus y1 is equal to x1 to the 4 minus y1 squared minus 2y1 x1 squared, okay? And f of x1 squared plus y1 is equal to x1 to the 4 minus y1 squared plus 2y1 x1 squared, okay? So let's check each of them. For example, this. For this one, we know we have three cases. It can be 0, so, or it can be this one squared, so x1 to the 4 minus y1 squared minus 2y1 x1 squared is equal to x1 squared minus y1 whole squared, or negative of that. So let's check negative of that. So here, if we simplify, x1 to the 4 will be cancelled from both sides. So negative y1 squared minus 2y1 x1 squared is equal to y1 squared minus 2y1 x1 squared. So you can cancel these two sides, so y1 is 0, and that's a contradiction, okay? From here, what can we conclude? x1 to the 4, x1 to the 4. Here, it would be negative x1 to the 4 minus y1 squared plus 2y1 x1 squared, okay? And then we can cancel negative y1 squared, and so it would be, if we take this to left hand side and this one to left hand side, so it would be 2x1 to the 4 minus 4y1 x1 squared is equal to 0. We can divide both sides by 2, so x1 to the 4 minus 2y1 x1 squared is equal to 0. Because x1 is not 0, we can divide both sides by x1 squared, so x1 squared minus 2y1 is equal to 0. Okay, so we have two cases here. One case is this one. One case is this one. Okay, now let's consider second equation. Again, this one can be 0, one case, or this one can be x1 to the 4 minus y1 squared plus 2y1 x1 squared can be this whole squared, x1 squared plus y1 squared. Or we can say what? We can say this one is equal to negative of that, okay? So here we have x1 to the 4 plus 2y1 x1 squared plus y1 squared. We can cancel x1 to the 4. We can take these to right hand side, these to right hand side, so 0 is equal to, and we can divide both sides by 2, y1 squared plus, oh, we can cancel also something. We can cancel this and this. Okay, so y1, 2y1 squared is equal to 0. So y1 is equal to 0. That's a contradiction. For this one, we can say negative x1 to the 4 minus y1 squared minus 2x1 squared y1. Now we can cancel negative y1 squared from both sides. We can divide x squared. Let's take all things to left hand side. We can say 2x1 to the 4 plus 4y1 x1 squared is equal to 0. We can divide both sides by 2x1 squared. So it will be x1 squared plus 2y1 is equal to 0. Okay? So now again we have two results. This one or this one. Now let's consider the thing. So we should consider four cases. From first equation, we can reach this or this one. From second equation, we can reach this one or this one. Okay. Now we should check. Let's consider these two things first. If we consider these two things, then x1 squared is 2y1 from here. x1 squared is negative 2y1. So 4y1 0, so y1 is 0. Okay, so we've rejected this case. Let's use different colors for proving each of them. Now let's consider this one. From here, x1 squared is 2y1, and if we replace here, it's 4y1 squared minus y1 squared plus 2y1 times 2y1. 4y, it is equal to 0. 4y1 squared, 8y1 squared minus y1 squared, 7y1 squared is equal to 0. So y1 is 0. Okay, again, that's a contradiction. Now let's consider this one. Again, by similar approach, you can say, okay, x1 squared from here is negative 2y1, and if you replace it here, it's 4y1 squared and minus y1 squared minus 2y1 minus 2y1 is equal to 0. So again, 4 plus 4, 8 minus 1, 7, y1 squared is equal to 0. So y1 is equal to 0. Okay, that's a contradiction. Now let's check last one, this case. So if we subtract this or this minus this one, x1 to the 4 and negative y1 squared would be cancelled. So 4y1 x1 squared is 0, and that's a contradiction because we said x1 and y1 are not 0. So we reach contradiction, we can have only one of them. So first answer is f of x is equal to 0 for all x's. Say next one, f of x squared. And last one, f of x is equal to negative x squared. Let's check our answers. So main equation is this. Always check in main equation because maybe you have careless mistake. You should check it like this. So for 0, case 1. 0, 0, 0, 0 plus 0, 0. So it's correct. Second one, f of x squared. This one would be x squared minus y squared plus 2y x squared. X squared would be x to the 4 plus y squared. Is it correct one? If you raise this side to the power of 2, it's x squared minus 2y x squared plus y squared plus 2y x squared. Y, it is equal to x to the 4 plus y squared. 2y x squared, negative 2y x squared would be cancelled, so x to the 4 plus y squared, x to the 4 plus y squared equal. So it is our second answer. Let's check third one. For third one, we say what? It is equal to negative x squared minus y whole squared plus 2y negative x squared, and this one, it's f of negative x squared plus minus y squared. And this part would be what? Negative this one squared, negative x squared squared. We want to see are they equal or not? Minus y squared. This one would be what? Minus x to the 4 minus y squared plus 2yx squared minus 2yx squared. So we can cancel these two terms. Here it would be what? Negative x to the 4 minus y squared. They are equal. So we proved third one also is an answer. Let me tell you a homework to solve similar to this one. Okay, try this IMO problem as homework 1. If let's review what are the ideas we used. Idea 1, 2, 3, get rid of complicated term. And then, I can say one more important idea, idea 4. Try to, for example, when you use 3, we try to find something inside itself. We calculate something with two different ways. We can call it also double counting is for combinatories, but with two different approach, you can find something. When you can find something inside itself. Idea 4 and okay, you should check at the end. You should check these things. Okay, 4 ideas. And then you can try this IMO problem.